I got one, Tom. Okay, we have problems dealing with absolute value. I think the first, I gave you 1 through 32, but 1 through 18 were absolute value equations. Are there any questions about 1 through 18, the equations? Any problems you'd like to see work? Tim? 13. Let's take a look at problem 13. Let's see what happens there. Oh, problem 13. Problem 13. It says the absolute value of 1 plus 3x over 2 is equal to 1/4. This says that when you're going to take the absolute value of this number inside the absolute value symbol, you're going to come out with 1/4. Well, the only numbers you can take the absolute value of and come out with 1/4 is 1/4 and negative 1/4. So this number inside the absolute value, that's 1 plus 3x over 2, has to equal 1/4, or it has to equal negative 1/4. So what we have here are two equations, rather easy equations. First step, clear fractions. Well, our LCM here is 4. We're going to multiply each term by 4, both sides by 4. We get 4 plus 6x equal 1. Correct? Okay. Now we're going to add a negative 4 to both sides. We get 6x equal negative 3. Divide both sides by 6. We get x equal negative 3 over 6, which is negative 1/2. And there's one solution. Now we're going to do the same thing to the other equation. Our LCM again is 4. So if I multiply through, I get 4 plus 6x equal negative 1. Adding a negative 4 to both sides, I get 6x equal negative 5. Divide both sides by 6, you get x equals negative 5, 6. So the solution set for that particular equation is x equal negative 1/2 and negative 5, 6. That's number 13. Okay? Remember, the same rules apply. Solving equations. Any other problems, 1 through 18? No. Problems 19 through 32, now what we did is we changed the words there. Instead of having equal, we either had greater than or less than, but they were still basically the same. Are there any there you'd like to see work? Yes, 25. Problem number 25. It says the absolute value of 4 minus x is less than or equal to 8. Now, what we're going to do is we're going to write this in equivalent form without an absolute value. And the key word there is less than. Now, we had a property that says that anytime the absolute value is less than a, then x, whatever is in the absolute value symbol, has to be between the negative a and a positive a. So if I use that property, I get negative 8 is less than or equal to 4 minus x is less than or equal to positive 8. So there we have it. It's equivalent form without absolute value. Now we have to solve this. So what we're going to try to do is get x all by itself in the center. You could break this up into two sentences, but it's easier to add a negative 4 to all three sides, and you come out with this. Now remember, what we want to do is we want to find out what x is. We don't care about 4x or 7x. We don't even care about negative x. We want to know what x is. If it's not just plain x, we have to divide everything by its coefficient. The coefficient is negative 1. So we're going to divide all three sides by negative 1. I get 12, I get x, I get negative 4. But since I divided by a negative, I have to change the symbol. Reverse the order. So now we graph this. Well, let's see what this says. Here's 0, here's 12. Here's negative 4. It says x Well, 12 is greater than x. If 12 is greater than x, then x must be less than 12. We put a bracket at 12 facing to the left. This says also that x must be greater than negative 4. So we put a bracket at negative 4 and we darken in everything. There it is. Problem number 25. Okay? Any questions?
Can you try 29?
Can I try 29? Why not? 29. 29.
Yeah.
The absolute value of x minus 2 is greater than 5. Our key word here is greater than. Again, we had a property for absolute value of x being greater than a. We discovered yesterday that that meant that x had to be greater than a, or x had to be less than the negative of a. So we have to take this out of absolute value form, put it into its equivalent form, which says x minus 2 must be greater than 5, or x minus 2 is less than a negative 5. You now solve these, and these are very trivial. You get x is greater than 7. Here you get x is less than negative 3. You now make the graph of this. There's 7. It says x is greater than 7. That means put a parenthesis at 7. Darken in everything to the right. Negative 3. It says x is less than negative 3. That's a parenthesis at negative 3. Darken in everything to the left. And there's the solution set for number 29. Tony?
Could you write that equation the same?
Yeah, it's similar, but I find students get confused with it, so I don't break it down. I keep it into 2.
Yeah.
Okay? Any questions? Now, I told you you're going to have 3 absolute values on the test tomorrow. One will be equal. I work one equal. One will be less than. I work one of those. And one will be greater than. Work one of each. You're definitely going to have one of each tomorrow. Okay. Today we're going to review a little bit. We covered the unit on sentences, and all our sentences were first degree. Now, by first degree, I mean the exponent of the variable was always 1. So let's review. I told you that the first set of problems, you're going to have 6 problems, and they're going to be equations. Some will be very simple, some will be more complex. So let's take a look. On the board I have an equation. Our job is to find the solution set. We want to find the value of x that's going to make this a true sentence. Now remember what I told you. Anytime you have more than one term in a fraction, for safety factors, enclose it in parentheses. Now, the first step in solving any equation is to clear fractions if you have them. We have them. So we find what's called the LCM, the lowest common multiplier. What we're going to do is we're going to find a number that all these numbers divide evenly into. Therefore, when we multiply each term by it, the fractions will disappear. The LCM for this problem will be 30. That means we're going to multiply both sides by 30, or each term. If we multiply the first term, we have 5 into 30 is 6, times the quantity, 2x minus 1. we multiply the second term by it, we get 6 and a 30 is 5, so we get negative 5 times the quantity x minus 8 equal 3 and a 30 is 10 times 2 is 20. And there we have an equivalent equation without fractions. The second step is to clear parentheses. Well, we have parentheses. We multiply through, we have 12x minus 6 minus 5x plus 40 equal 20. And there the parentheses are removed. Step 3 says to combine like terms. Well, here on the left we have 7x plus 34 equal 20. Step 4 says get all the terms with x on one side. Notice we have all the terms with x on one side. Step 5 says get all the terms that don't have x off that side. Well, I have to get rid of the 34. I add a negative 34 to both sides. You get 7x equal 14. Last step says divide both sides by the coefficient of x, which is 7. So if we divide both sides by 7, we come out with x is equal to negative 2. How can I check to see if this is right or it's wrong or whatever? How can we check this? Kathy?
Negative 2 in there.
Yeah, go back to the original equation. Every place you have an x, replace it by negative 2. If you do that, it should make this a true sentence. And it will. Okay? Any questions on that? Okay, let's take a look at another equation, a little bit more difficult. Let's see if we can find one here. Two x minus 1 over x squared plus 4x minus 5 plus x minus 2 over x squared minus 10x plus 9 is equal to 3x minus 12 over x squared minus 4x minus 45. Minus 5, yes. Okay. X squared minus 10x plus 9. Last is 3x minus 12 over x squared minus 4x minus 45. Now, notice what I've done. I have enclosed my numerators in parentheses. We now must find the LCM. Remember, we find the LCM the same way we find the LCD. That means we have to factor each one of our denominators. If we do, we have first denominator becomes x plus 5, x minus 1. Second denominator becomes the quantity x minus 9 times the quantity x minus 1. And the last one becomes x minus 9, x plus 5. And there is each denominator factored into prime factors. We're now ready to find the LCM. We take everything from the first. That will be x plus 5, x minus 1. From the second, we need an x minus 9. Now this is what we're going to multiply each term by. Each term we're multiplying by this LCM. Now notice, if I multiply the first term by it, the x plus 5s are going to be a 1. The x minus 1s will divide. All I'm going to have left is the quantity 2x minus 1 times the quantity x minus 9. Plus, we multiply the second term by it, the x minus 9s divide out the x minus 1s. We have x minus 2 times x plus 5 equal. We multiply the third term by it, the x minus 9s cancel, the x plus 5s cancel, so we come out with the quantity 3x minus 12 times the quantity x minus 1. And there we have an equivalent equation, no fraction.
X plus 1.
Say again?
Shouldn't it be X plus 1?
No, it's x minus 1. Okay? So the next step says, hey, clear parentheses. Well, we have quite a few parentheses here. We clear them. We FOIL. We come out with 2x squared minus 19x plus 9 plus x squared plus 3x minus 10 equal 3x squared minus 15x plus 12. And there the parentheses are removed. Third step says combine like terms. Well, if I do that on the left, I have 3x squared. I have a negative 16x. And I have a negative 1. Notice in this problem, when we combine like terms, we have a second degree term there. We better lose it because, as I said, we don't know how to learn how to play with second degrees for the next lecture. So we add a negative 3x squared to both sides, and sure enough, they're gone. Step 4 says get all the terms with x on one side. It doesn't make any difference which side you bring it on. I'm going to add 16x to both sides. I'm positive 16x. If I do, I get negative 1 on the left. On the right, I get x plus 12. Step 5 says get all the terms that don't have x off that side. Well, I have to get rid of that 12. I add a negative 12 to both sides. I come out with x equal negative 13.
13.
13. Okay? Any questions on it? Okay? Now, I told you you're going to have 6 equations. One of those equations is going to be a literal equation. Example. Okay? A literal equation. Our job is to solve this for x. We want to solve this for x. We want to get x all by itself. Now, the format for solving the equation never changes. First step says clear fractions. Well, we don't have any fractions. Second step says clear parentheses. Well, we have parentheses. We have 2ax plus 6a is equal to 8a squared plus 3x minus 9. We have cleared parentheses. Step 3 says combine like terms on each side of the equation. Well, there are no terms that we can combine. Step 4 says get all the terms with a variable on one side. Get all the terms with x on one side. That means I have to add a negative 3x to both sides. And there I have added a negative 3x to both sides. This is what we have. Step 5 says get all the terms that don't have x off that side. Get all the terms that don't contain that variable off that side. Well, that means we have to get rid of the, what?
2ax
No,
and 6x.
no. Look over here, Lynn. We want to get all, how many terms do you see on this side?
Sure.
How many terms?
Sure.
Oh, come on.
But without x.
How many terms are on this side?
3.
3. How many of those 3 terms do not contain an x in it? 1. Just the 1. We want to get all the terms that don't have x off that side. That means we have to get rid of that 6a. We add a negative 6a to both sides. And remember, when you add it, put it in the proper place. Now the last step says, hey, divide both sides by the coefficient of your variable. Well, I don't know what the coefficient is. So what I'm going to do is I'm going to factor out an x over on the left. If I do, I get x times the quantity, 2a minus 3. Now remember what we mean by the coefficient. What are we multiplying that variable by? Now we can see what the coefficient of x is. It's the quantity 2a minus 3. That's its x's coefficient. Over on the right, well, we can factor it in. It's factorable. We factor that correctly. We have 2a and 4a. We have 3 and 3. We have a minus and a plus. Check the middle term. Hey, it works out. We now divide both sides by the quantity 2a minus 3, and we come out with x is equal to 4a plus 3. Okay? Literal equation. Same format, same procedure. Everything same. Okay, I said the first group's going to contain 6 equations. One of these 6 equations is going to be a formula. Example. P is equal to 2a times the quantity k plus 3n all over 5. And what I like to do is I like to solve this for n. For n. I want to get n. N's our variable. This is what we're going to strive to get all by itself. Now again, the procedure does not change. The only thing that changed, instead of having an x or y for a variable, we now have the n for our variable. First step says clear fractions. We have them. We multiply both sides by the LCM. Well, that's 5. If I multiply the left side, 1 into 5 is 5, I get 5p. Equal. If I multiply the right side, the 5's divide out, I get 2a times the quantity k plus 3n. First step, clear fractions. So what we have on the board is an equivalent equation, no fractions. Second step says clear parentheses. Well, we have parentheses here. If we multiply this through, we get 2ak plus 6an. Parentheses are removed. Third step says combine like terms. There's nothing we can combine there. Step 4 says get all the terms with your variable on one side. N is our variable. Do we have all the terms with n on one side? We sure do. Step 5 says get every term that doesn't contain this variable off that side. We want all the terms that don't contain n off to that side. So we have to add a negative 2ak to both sides. The last step says, hey, divide both sides by the coefficient of your variable. That means what you are multiplying this variable by. Well, n is our variable. What are we multiplying n by in this problem? 6a. That is our coefficient of n. And there you come out with the answer. N is equal to 5p minus 2ak over 6a. Okay? Okay. Now, I said you're going to have 3 problems dealing with inequalities. So let's take a look at one.
Big one, big time.
Okay. Now remember, we have properties of inequalities. And we found that the properties of inequality were basically the same as the properties of equation, with the exception of that any time you multiply an inequality by a negative number, or divide both sides of an inequality by a negative number, you have to reverse the order of that inequality. Otherwise, everything's exactly the same. So the first step would be clear fractions. We don't have any. Second step would be clear parentheses. Well, we have those. 14x minus 35 is less than or equal to 18x plus 6 plus 3. We have cleared parentheses. Step 3 says combine like terms. Well, over there on the right I can combine something. And we come out with this. Step 4 says get all the x's on one side. Now remember, as far as our solution goes, it doesn't make a bit of difference which side you bring the x's on. But I found that most students have less trouble graphing, not solving, but graphing the solution set if the x's are on the left side. So I'm going to add a negative 18x to both sides, and I get negative 4x, negative 35 is less than or equal to none. Notice our symbolism is the same, because our property says, hey, if you add equals to unequals, they stay unequal in the same order. You can add anything to both sides of an inequality and it has no effect on that symbolism. We're now going to add a positive 35 to both sides, and I get 4x, negative 4x is less than or equal to 44. The last step, divide both sides by the coefficient of x. Well, the coefficient of x is negative 4. I get x, negative 11. But since I divided by a negative, I have to reverse the order. Some students look at the answer, and if the answer is negative, they change the order. That's not true. The answer has nothing to do with that symbolism. It's what you are multiplying and dividing by that affects the symbolism. And since we divided both sides by a negative, that's what determines what we do with that symbol. And there it is. Now remember, dealing with inequalities, a part of the solution is drawing the graph of your solution set. This is automatic. Somewhere to the left of 0 we have a number called negative 11. Now we want to represent all the numbers that are greater than or equal to a negative 11. So we put a bracket at negative 11. We darken in everything to the right, including the arrow, and there it is.